Welcome back to Backspace Academy. In this lecture, we'll talk about AWS X Ray, which is an AWS back-end service that can provide insights into how your applications are running on AWS. We'll talk about how it works. How do we modify our application code to integrate with AWS X Ray? How do we collect information about our application's performance, and how do we pass that information on to the X Ray service so that we can see some visualizations and graphs of this performance? We'll talk about the X Ray daemon and what that is and how we can use that to collect information from the performance of our application and forward that onto the X Ray service. We'll talk about the permissions that our application and the X Ray daemon will need. We'll talk about the permissions that any users that want to access this data will need. And we'll also talk about the X Ray console, which allows us to view very detailed, fine-grained information in the format of lists and graphs and other visualizations of our data. And finally, we'll have a look at the X Ray development tools that are available to use with our application. The AWS X Ray service, it will collect data about requests that are served by your application. And you can look at that data to provide very fine-grained detail around the performance of your application. It consists of a software development kit, a daemon or daemon, and the actual X Ray console or X Ray service. Now, the X Ray software development kit, you need to include that with your application, and that will send trace information to an X Ray daemon that will receive that information. So the X Ray daemon, that will listen for UDP traffic from your application. It will buffer that data, and then in batches, it will upload it to the AWS X Ray service. And then the AWS X Ray service will provide data collation, analysis, and visualization tools that you can access through the AWS Management Console. Now, the X Ray software development kit, it provides interceptors that can trace HTTP requests to your application. It will have client handlers, and that will allow you to monitor calls to AWS services. For example, calls to Amazon S3 by your application. And there will also be a HTTP client that can monitor calls to other internal or even external HTTP web services. So the combination of that will provide a very fine-grained and detailed analysis of the performance of your application. Now, the first thing we need to do is that we need to include the X Ray software development kit in our application code. Once we've done that, the X Ray SDK can then send information or trace information to the X Ray daemon about what your application needs monitoring. Now, the X Ray daemon, it will be running on its own compute resources that you need to provide. So that could be on EC2, or it could be on a Lambda function, but we'll talk more about that later. And the X Ray daemon will get those instructions from the X Ray software development kit, and it will start to collect data about what is to be collected. And once it's got that data, it will collate that data and it will forward it on to, or using the X Ray API, it will forward that on to the X Ray service. Once that information has been forwarded on to the X Ray service, then end users can go into the AWS Management Console, go into the X Ray console, and then you'll have a range of visualization and analysis tools available to view the performance of your application. If you want to analyze that data yourself outside of the X Ray console, there are scripts and tools that are available. You can use the AWS command line interface to download that data, for example, and use it elsewhere. Or you can use one of the many AWS software development kits to create your own application to further analyze and visualize this data yourself. After our application has run, we can go into the X-Ray console and we can see here we've got a service graph, and that details segments of our application and subsegments of our application. And we can click on those and get more details about those specific parts of our application and how they are performing. So here we have some more information about the individual traces that are being monitored by the X-Ray daemon. So we can see here we've got a score keep segment of our application, and that is divided up into a number of different calls to AWS services there. So we can see there that we've got game model save game that's taken quite a bit of time. So we can see there is that there is an opportunity possibly to increase the performance of our application. When you use X-Ray, you break your application code down into segments, and your application code using the software development kit will forward information about those segments over to the X-Ray daemon. Now, those segments can also be broken down into further sub-segments that can provide even greater granularity. The segments information provided to the X-Ray daemon will include, among other things, the resource's name, details about the request, and details about the work that is being done. Now, the segment that is passed from the X-Ray daemon, which will contain that application data that is passed over to the X-Ray service, will be a JSON representation of a request that your application serves. And a segment document will be information that is provided through your application through the X-Ray software development kit, and that segment document will be passed on to the X-Ray daemon, and that will convey information about that segment and what to monitor with the X-Ray daemon. Now, the X-Ray software development kit, it will gather information from request and response headers. It will gather information from the code in your application, because the SDK can actually send information about your application directly to the daemon. And it can also monitor metadata and collect that data about the AWS resources which are running your application. Now, the type of data that can be defined or collected by the X-Ray daemon can be defined in the application's code through the software development kit, or in the X-Ray configuration through sampling rules. And we'll talk more about those coming up. Data sent from the X-Ray daemon to the X-Ray service is used to create a service graph. And that will show all of the resources that are sending data, and they will appear as services or round circles in that graph. And they will be connected with edges, and those edges connect those services that interact with each other. Now, this service graph is actually a JSON document that can be retrieved from the X-Ray service. And you can do that without even using the AWS console, and you can do that using either direct HTTP calls to the API, the X-Ray API, or by using the command line interface or the software development kit, if you want to analyze that service graph yourself offline, for example. The X-Ray daemon will collect in batches trace information to the X-Ray service for analysis. Now, a trace is a collection of all of the segments and subsegments that are generated by a request. And the X-Ray daemon will use a trace ID, which we use to track the path of a request through all of those segments and subsegments. Now, the service graph data, that will be retained for up to 30 days. So if you want to keep it for longer than that, you're going to have to download that yourself. And it can be retrieved using the command line interface with the get service graph command, or through the API, the X-Ray API, or one of the number of software development kits. By default, the X-Ray SDK will define to record the first request each second and 5% of any additional requests. So it doesn't record every single request, but it takes a sample of those requests. Now, those samples are defined in the sampling rules, and they can be created to modify that default behavior. So you can control the amount of data that you record and modify that sampling behavior on the fly. So you don't need to shut anything down. You can do it on the fly without modifying or redeploying your application code. So those sampling rules, they can be changed through the X-Ray console or through the command line interface using the update sampling rule command, or the X-Ray API, or one of the many software development kits. The X-Ray daemon, it will listen for UDP traffic from your application through the AWS X Ray software development kit. You must provide a compute resource to run the X-Ray daemon. AWS doesn't do that automatically for you. You need to make that happen. And once you've done that, the daemon endpoint must be supplied to the X-Ray software development kit on your application so that it knows where to send the segment documents to. Now, the daemon compute resource must also have IAM permission to communicate with the X-Ray service. So appropriate compute resources for running the daemon, you can obviously run it on an EC2 instance. You can run it as a container on an instance using ECS. You can also use the Elastic Beanstalk service to create a process on your Elastic Beanstalk EC2 instances that will run the daemon automatically for you. You can run it on AWS Lambda as a Lambda function, or using the compute resources of your application that is running on AWS Lambda. And finally, you can use it locally, or you can deploy it locally on a Linux, Mac, Windows, or Docker container environment. Now, if you're going to be using the X-Ray daemon on a Lambda function, when you trace your Lambda function, the X-Ray daemon will be automatically running in the Lambda environment. But the X-Ray daemon, you need to consider that it consumes the maximum of 16 meg or 3% of your function's memory allocation. So if that becomes a problem for you, you need to look at doing something different. So Lambda, if you exceed your function's memory limit, will try to terminate the X-Ray daemon. So to avoid that, if you want to make sure that the X-Ray daemon is running all the time, you need to increase your function's memory limit or run the X-Ray daemon as a separate Lambda function. In order to use the X-Ray service, your users, your application, the X-Ray daemon that you're running on a compute environment will all need to have permissions set up in order to use that service. So if a user wants to use the console to have a look at the data that has been visualized, they will need to have permission to get that information. So there is a managed IAM policy called AWS X Ray read-only access. And if that managed policy is applied to a user, they will be able to get access to that information through the console. The SDK and the X Ray daemon that you are running will need to have write access to the AWS X Ray service. And so there is again a managed IAM policy to do that. And it's called AWS X Ray daemon write access. Put trace segments is a permission that the AWS X Ray software development kit that will be running on your application will need to pass segment documents to the X Ray daemon. And put telemetry records will need that permission applied to the X Ray daemon for it to pass its telemetry records over to the AWS X Ray service. And if you want to configure encryption key settings or sampling rules, you'll need to have AWS X Ray full access. And that simply has action in your policy, X Ray, and then the wildcard symbol to give full access. If you want to do local development and testing by running the X Ray daemon on your local environment, on your local computer, then you'll need to have IAM user credentials that will have AWS X Ray full access to enable you to access those resources that are running on AWS. The X Ray service map is a visual representation of that trace data that is sent from the X Ray daemon. Now, it consists of round service nodes and edges between those connected nodes. So a service node, you can click on it to view requests generated for that node. And you can also click on the edges between nodes to view requests that are traveled between those two service node connections. You can also view a histogram of traces by duration, and that will help you to track down the problem areas within your code by looking at those long duration traces. The health of each node will be color coded: green for successful calls, red if you've got any server faults, and yellow for client errors. For example, if your client made a request for a page in a web application that didn't exist, then you'll get a 404 error, and that will come up as a yellow in the node. And finally, purple for throttling errors in your application. So here we can see we've got a service map with most of it in green, but we have something in red, which defines that we have a server fault going on there. There's a problem with our application server. We can see there we've got those service nodes, and we've got the edges that connect between those related service nodes. Here we can see we've got another service node with a problem, but it doesn't exist in all of the traces, only part of those. And so part of those have got a yellow error, which means it's going to have a 400, a client-side error. For example, if your client that is accessing your application makes a request for a web page that doesn't exist. And here we see we've got a histogram of a trace, so it helps us to identify where the majority of these problems are occurring with that trace. We can also add colors to that, so we can have it so that it will show different types of traces. For example, if they're okay or if they've got errors, and they will come up as a color coding on that histogram. The trace list in the X-Ray console can list traces by URL, response code, and any other data from that trace summary. The trace ID itself can be clicked to view a timeline for all of the requests that will be displayed as a hierarchy of these segments and the subsegments of that segment. Clicking on a segment or subsegment in that timeline will display a form that will have a number of different tabs. There's an overview tab that will give you the segment details, the time, the errors and faults, the request and response information. There's a resources tab, which of course will detail the resources involved in that segment. And there will be an annotations, metadata and exceptions tab as well. You can filter the data using filter expressions, and that allows you to narrow those results down. For example, if you just wanted to get the traces that had a duration of greater than or equal to 5 milliseconds and less than 8 milliseconds, that is how you would enter a filter expression for that. And you can also download or you can access the raw trace data itself in JSON format. There you can see we've got a trace list, and it has a number of fields there, being ID, age, method, response time, the URL. And you can simply, by clicking on those carets there, you can filter that or organize that based on any of those features there, being age or response time or URL or whatever. And if you click on any of those segments or subsegments within that trace list, that will open up a hierarchy or a graph of the hierarchy of the segment and its subsegments there as well. And it will also show the different times, and which is very good to visualize exactly where the performance is being lost or gained. And clicking on a segment within that graph, you will get this form, which will have the overview, resources, annotations, metadata, and exceptions tab there, which can again give you more information that you may need. And if the amount of results that you get is too much, and as you can see here comes a warning saying that the scanned results is more than 1,000 matching traces, so then you can go in and you can adjust your filter expression to narrow those results. And finally, you can always have a look at the raw data in JSON format there, and you can always copy and paste that into a JSON editor and have a good look at that if you wish. There are a number of development tools that are available for the X-Ray service, and those are provided through the X Ray API. and it provides access to all X-Ray functionality through either direct HTTPS calls to the API endpoint, or by using one of the many AWS software development kits, or using the AWS command line interface. If you are going to be using the X-Ray service to monitor performance data from your application, there are a couple of put functions in the SDK that you need to be aware of, or in the API or CLI. The first one there being put trace segments, and that allows the SDK or the API or the CLI to upload segment documents to your X-Ray daemon. And that will describe exactly what you want to monitor in your application. And finally, put telemetry records. That allows the daemon to upload telemetry information or data to the X-Ray service. So that brings us to the end of a pretty complicated lecture, but the best way to learn this is to get your hands on it. And coming up next, we're going to have some labs, very detailed labs on the X-Ray service. I look forward to seeing you in those.